As I said in the introduction, the shape operators give your particles form at render time, and are the only way to achieve this without resorting to specialist volumetric systems such as Sidney-Satney's afterburn. In general, shapes are polymesh surfaces, though in the future it may be possible to define and render parametric surfaces such as those seen in the Power Solids plugin. Let's have a look at what we have currently in this set. The first operator is the shape operator, which I'll actually show you here. Here you can see. And the shape operator offers the most basic options of any of the shape operators in this set. You can simply choose a basic shape, an initial size for it, and if you wish, a scale. Let's have a quick look at the options. You can see that you have a flyout here called shape, and in there you can see you have 4 choices. I'll actually run through these in reverse order for a reason that'll become clear in a second. You can see the last option is sphere, which you can see is active at the moment. You have a cube, you have a tetra, which is basically a triangular pyramid, and you have a vertex. Now you can see that when I chose vertex, our particles became invisible. And that's because in the display operator, which we'll come to later in the DVD, I've actually set the display type to being geometry. And the reason for this is that the shape generally will be one of these types, these geometry types. This is a geometry sphere, this is a geometry cube, and this is a geometry tetra. And if you want to be able to see these in the viewport, you have to set the display operator to geometry. So, as an example, if we had it set to ticks, and we went to the shape operator, and we set it to tetra, you can see we'd end up with ticks. If we set it to cube, we'd still have ticks. Sphere, we still have ticks. So you can see that the display operator needs to be in geometry mode to actually see any geometry on your particles. Let's go back to the shape operator. The size parameter is very simple. It's actually the size of the particles. So as we grab the spinner and move it up and down, you can see that the particles get smaller and larger. And that works the same for all of the others, obviously. And I would imagine the same is actually the case with the vertex as well. This size value is stored, and it can be used by scripts later. And what that would mean is that a value would be assigned, but there would actually be no geometry on those particles. But you could actually assign that geometry in a script later. So this is a kind of phantom shape type. So separate to this, we have an option to turn on scale, and after we've actually applied a size to our particles, we can then immediately scale it. And if you remember from the scale operator, you'll remember that there is a difference between size and scale. So as you can imagine, size is the real world actual size of the particles, and scale is a scale transform which is applied to them. And it's pretty much the same way that geometry works in the rest of Max. You have a real size of an object in world units, and then you have a scale transform applied to it, and those two things are quite separate. So that's basically it for the shape operator. Due to its basic options, this operator is generally best used when prototyping your flow without some geometry to display. The scale and rotation operators are pretty hard to visualize. So you can use these basic shapes to actually get an idea of what those operators are doing. I'll show that now with a quick example. If we take a spin operator, for instance, if you were to show your particles as ticks, you wouldn't really get a very good idea of how your particles were spinning. So if I put that spin operator here, you can see we've got spin random, and now we've got a shape. I'll change it to tetra as it makes spinning more obvious. And now if I scrub the timeline, you can actually see the spinning in action. It's quite obvious. If I go to display, change the display to ticks, and do the same thing, you can see you can't actually see the spinning in action whatsoever. So there are a number of operators which actually need some kind of geometry on your particles, so you can get an idea of if they're spinning correctly, or if they're rotating to the right axis, or are they scaled correctly, and so on. So generally the shape operator is used as a utility shape assignment system. But of course, if your particles are very small, they are literally particles like dust or sand and so forth, the very basic options that you have here, the tetra, the cube and the sphere, can actually be good enough for what you want to render. Okay, so that's it for the shape operator. Let's move on to the shape facing operator.